What's up everybody? Welcome back to the Hive and welcome back to another Unreal Engine 5 tutorial. In this video we're going to take a look at the new global illumination and reflections technologies for Unreal Engine 5 named Lumen. We're going to take a look at the settings and how to activate them for your own project. We're going to take a look at how to set up lighting for a brand new scene, as well as take a little dive into the documentation to understand Lumen more and see what the limitations are. So let's jump right in. Here we are in the project that we made in the previous tutorial. It is just a third-person blueprint project. I didn't change anything. So let's first take a look at the settings to understand how Lumen is activated. So here in the project settings under Engine and Rendering, if we go back, there's a global illumination section in here. This should be set to Lumen. And there's the reflection method that should be set to Lumen also. These are by default for any new Unreal Engine 5 project, but if you are migrating an Unreal Engine 4 project, these will not be set, so you need to set them yourself. There are also some other interesting settings in here that we will go over. There's the software ray tracing mode. By default, it's the detail tracing. It is the higher quality tracing that is done in the mesh's individual distance field. And there's the global tracing that is done in the global distance field, and that is less performance consuming. There's the shadow map method. The virtual shadow maps beta are the new ones, and the shadow maps are the old one. We will see how these work and what they do. We have the support hardware tracing here. If you have hardware that supports hardware tracing, you can check this, and then you can check the use hardware tracing when available. And the Unreal Engine 5 will use hardware ray tracing when available, and if not, it will default back to software ray tracing. We have the generate mesh distance field here that should be checked if you use the reflection method Lumen. It should be checked by default with the reflection method, but if not, pay attention to this. And then we have the allow static lighting that is checked by default, and Lumen does not use static lighting. So if you want to just be sure that there are no static lights in your project, you can just uncheck this. Be aware that if you uncheck it, you will have to restart the project and it will recompile shaders. And as all of us Unreal Engine developers know, recompiling shaders can take a lot of time. So maybe do that when you are about to take a coffee or take a break. And that is all for the settings. Let's now jump into a new scene and see how we can light a scene from scratch. So let's create an empty level. So there are nothing here in this level, no lights, no objects. Let's start by creating a shape. We create a plane, put this at 0, and let's make this 100 by 100. Let's create a cube in here, put this at 0. Let's make this 10 by 10 by 10. Take this out. Let's create a sphere. So our scene has some objects, but there are no lights in here. So the way we used to do it before was in the button that was like this create button here in Unreal Engine 4. We used to do create and lights and add our lights. Same for visual effects and for our volumes. But I discovered a hidden menu in Unreal Engine 5 that makes this process so much easier. So if you go under Window and Environment Light Mixer in here, you can just create everything that you need. So let's start by creating a skylight. Let's create an atmospheric light. Let's create a sky atmosphere. Let's create a volumetric cloud. And here we have the details of all our lights. So of course they are still selectable here in the World Outliner, and we have the details in here. But here we have access to all the lights one under the other. We have this setting set to minimal. I move it to normal to have a little bit more settings. And when you create all your lights, there's a little bug. So if you come to the directional light and just click this and hit OK, it will reload the directional light. And there is one other thing that I like to do is to go to my skylight and click the real-time capture, which is going to make the lighting a lot better. And as you can see, we have this black area in here that normally in a real game level, we would have outskirts and we will not see this, but an easy way to remove it is to go to create visual effects and add an exponential height fog. And that's all we need to do to have a great lighting for our scene. So now let's start playing with these. And before I do that, let's add another object to our scene. Let's add this, put it in here. So this is just an object that is used to calibrate colors, and it gives us some reflections and some things to look at. So let's start going over our options in here. So the directional light, the first option we have is the source angle. And the source angle is actually the size of the light. So if you look at the sun in here, if I move this up, the sun gets bigger, and we can get a little bit crazy with that. And what this does is it actually, as in real world photography or filming, when you want soft shadows, you need a bigger source of light. And if you have a small light source, your shadows are going to be very harsh. So if we look at the shadows in here, if I make the source angle bigger, you can see that the edges of the shadows get more and more soft, which is really nice and makes the shadows really realistic. And these are the new shadow maps. So if we go to the settings in here, under rendering, we have our virtual shadow maps in here. So if I change this to the shadow maps we had before, you can see that the shadows do not look really good. These are the shadows that we are used to have in video games. But if we put virtual shadow maps, the new ones, they look a lot better. They line up with the objects a lot better, and they just look awesome overall. So if you want to make the shadow edges a little bit more soft, you can play with the source angle in here. So we can really get crazy with this and have some very, very diffuse shadows and a sun that is the size of the universe. So let's take this back to, let's say 3. Under that, we have color temperature. So we can check this and we can play with the color temperature if we want a really cold scene or a really warm scene. We have the light intensity, of course, that we can play with to make the light more intense. We have the light color that we can change a little bit to a color that we like. And then we have our effect worlds that just deactivate the light if we want to test things, and cast shadows that remove the shadows if anyone would like to use that for some reason. And atmosphere and cloud, here we can completely deactivate sunlight if we want. And we can also have shadows cast clouds. So it gives a little bit more depth to the shadows and to the atmosphere. And it makes the entire world a little bit more shadowy, if that makes sense. And that's everything we will cover for directional light. Let's move on to the skylight. So skylight, we already activated real-time capture, which makes light a lot better. Here we have the cube map resolution that we can augment a little bit. Intensity, it's the intensity of the skylight. Light color, the same. We can play with this. There are many properties where we can change the colors of different things in our lighting to really get the lighting that we want. And of course, effect worlds the same if you want to deactivate the light, and cast shadows for the skylight doesn't do anything. We have indirect lighting intensity. It doesn't do anything for skylight, but it's actually useful here in directional light. So if you look at these areas that do not have direct lighting, so if we augment the indirect lighting intensity, we can see that we are making them a lot lighter. And if I take that down, we can make them a lot darker. So this is the intensity of the indirect lighting. So that's all for skylight that we're going to cover for now. Sky atmosphere is where we can tweak our atmosphere to really have the atmosphere that we want. So we can tweak the atmosphere height. We can tweak the different colors in our atmosphere. There are different spots that we can change around the sun, the color of the atmosphere behind the clouds and all that. So we can play with this to really get the effect that we want. And in the end in here we have the volumetric cloud. So the volumetric cloud are the new cloud system. So you can tweak the altitude of the clouds. You can tweak the height of the cloud layer, and you can change the material in here to have clouds that you want. The last thing we're going to see is the exponential height fog that we added in here. So here we can play with the fog density if we want some really dense fog, and we can play with the fall off and with some other different, the color and some other different properties to really make that the way we want. So let's open our example map that we have in here, and let's, this is lit with the old way of doing things. So let's just remove all this and light it with the new way of doing things and see how it looks. So let's just play for reference. Well, it does look like Unreal Engine 4, the way we remember it. There's no indirect lighting. The scene looks like it's lit the same way everywhere. So let's just start deleting this. So delete the light source, map, post-process, skylight, atmospheric fog, sphere reflection capture, sky sphere blueprint. And we have deleted all the lights. So now we can start creating our skylight, our atmospheric light, our sky atmosphere, our volumetric clouds. Let's go in here and just hit OK to reload the lighting. Let's go to our skylight and check the real-time capture. And it already looks a lot better. And if we go here, we can see that there's still this dark area. So let's add exponential height fog, and will you look at this? So let's go to our directional light, make the source angle a little bit bigger to get softer shadows, and hit play. And this to me looks 100 times better than what we had before. And we haven't tweaked anything. We just clicked in 5 spots. And this is how good the new lighting engine is in Unreal Engine 5. All right. So now let's take a look at the documentation and understand a little bit how Lumen works and the limitations of it. So they start by explaining how to activate Lumen in the settings. So we've already went over that. So here with Lumen Global Illumination, light bouncing off diffusely off a surface picks up the color of that surface and reflects the colored light onto the nearby surfaces. This is called color bleeding. Meshes in the scene also block indirect lighting, which also produces indirect shadowing. So let's take a look at color bleeding. If we go back to our test light map in here, so let's take this object and let's put an emissive material on it. So let's put this. Here you can see that the light that is bouncing off the object and to the ground, you can see that it's changing the color of the ground. So this is what they mean by color bleeding. And if I hit play and go next to it, you can see the reflections on my character that also change color. Let's take something else. For example, let's take this gold and put it in here, and it should do the same. So I don't know if you can see this through the YouTube compression, but there's actually a little bit of golden and yellow in here. So indirect lighting doesn't only bounce light, but it also takes into consideration the color of the surface that it's bouncing on. Let's keep going. Lumen with the skylighting. So skylighting is solved as part of Lumen's final gather. This includes sky shadowing, which allows indoor spaces to be much darker than outdoor. This is really awesome. Actually, it makes the lighting a lot more, lot like real life. Actually, so if we go back to our example map in here, let's hit play. So here we are. We are completely away from the direct lighting. So it's like if we were in indoor space. So when I will go outside this area, light is going to soften. So if you see in front of me, like the shapes are really completely white in here. So if I go out of this, you can see that the light softens and dampens a little bit to adapt to the lighting. So if I come here, it lights up. And if I go here, it dampens the light for a more realistic effect. I think this is really good. This makes it look a lot more realistic. All right, let's keep going. Lumen and emissive materials. So emissive materials propagate light through lumen's final gather with no additional performance cost. This is awesome. So as I just did, so if you have an emissive material on an object, it's gonna propagate and it's gonna bounce that light, and it will not cost anything more in terms of performance. A very good point. Supported light types and other features. So all light types are supported. This includes directional, sky, point, spot, and rectangular lights. Light functions are supported on directional lights only, and lights with their mobility set to static are not supported because static lights are stored completely in light maps and their contribution is disabled by Lumen. So as we said before, static lights are not supported, or your lights need to be stationary or movable, and you can also completely deactivate the static lights from the settings. So here they go over the settings. We already seen all those. Lumen is compatible with post-process, so you can have a post-process volume that is going to override your project settings in terms of global illumination and reflections. So in your post-process, you can set your global illumination method to Lumen and your reflection method to Lumen, as you do in your project settings. And you can also fine-tune the quality. So the final gather quality, you can fine-tune it, and the quality of your reflections, you can tune it. So final gather quality increases the quality of lumen global illumination and reduces noise being rendered, but will increase the GPU cost of rendering it, and the same thing for the quality of the reflections. And some additional notes. So Lumen lighting update speed. So Lumen uses a number of caches to achieve real-time performance. While local lighting changes propagate quickly, global lighting changes like disabling the sun can take multiple seconds to propagate. So let's take a look at this. So here we are in our scene. If we take our directional light and we completely deactivate the sun, you can see that it takes some time to update the lighting in here. Let's reactivate it. And it takes like a second or two to completely change that. So this is something that you should avoid doing in real time. And that is all we're going to go through for this documentation. Let's jump into the the technical details, and see what we can find in here. So Lumen ray tracing, as we said, there is a software ray tracing and hardware ray tracing. Here they give a little bit more detail about the detail tracing and the global tracing. So the detail tracing actually traces against the individual mesh's distance field for the highest quality, using the first 2 meters for accuracy, and then the global distance field for the rest of each ray. Global tracing is just the global distance field for the fastest traces. Let's look at some limitations. So in terms of geometry, it only supports static meshes, instant static meshes, and hierarchical instant static meshes. It does not support landscape, but it will be supported in a future release of the engine. So for now, Lumen and also Nanite, they do not support landscape, but I saw actually on Reddit that a guy just converted his landscape to a mesh, to a static mesh, and put it in the engine, and it actually works well with Lumen and with Nanite. So that might be a workaround while waiting for the next release of the engine. Some workflow limitations. So software ray tracing requires levels to be made out of modular pieces. Walls, floors, and ceilings should be separate meshes. Large meshes like mountains will have poor representations and may cause self-occlusion artifacts. And walls should be no thinner than 10 centimeters to avoid light leaking. And for large worlds, I will not read all this, but basically, Lumen does not need Nanite to operate on large worlds. But if you have large worlds with a lot of high poly objects, Lumen will be a lot slower than normal. So you should either have a look at Nanite or have LODs that are set up correctly if you want to use Lumen for large worlds. Fast camera movement will cause Lumen scene updating to fall behind when the camera is looking, where the camera is looking, causing indirect lighting to pop in as it catches up. Lumen surface cache covers up to 200 meters from the camera position. Past this, only screen traces are active for the global illumination. So if you are moving really fast past those 200 meters limit, your global illumination is going to lag a little bit behind. And some other limitations in here. So Lumen cannot be used with static lighting. We already seen that. Foliage is not well supported in this early access build because of the heavy reliance on downsampled rendering and temporal filters. Lumen's final gather can add significant noise around moving object and is still under active development. Translucent materials are not yet supported for Lumen reflections and will not have high quality dynamic global illumination. And for the platforms, Lumen does not support current gen platforms, PS4 and Xbox One. They give some alternatives in here. And Lumen does not support mobile platform, and there are no plans to develop a dynamic global illumination system for the mobile renderer. Games using dynamic lighting need to use unshadowed skylight on mobile. And that's it, guys, for the documentation. So I hope you guys enjoyed this tutorial. If that's the case, please hit that like button. Helps the channel a lot. If you're not subscribed yet, please consider subscribing. If you're interested in game dev, game design, and Unreal Engine 5, we will be doing a lot more tutorials. And as usual, my name is Anas. Thank you very much for watching, and I'll see you guys in the next one.